first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm Geologist Philip Ong. I'm here with Mr. Dane DuPont, HawaiiTracker.com. Here to bring you guys another Kīlauea volcano update. Today on February 23rd, 2021, 65th day of this ongoing Kīlauea summit eruption in the pit of Halemaumau crater. Dane will be manning the chat and taking questions that we'll address a few of the best ones there at the end. And making sure streams are running smoothly and all that. So mahalo, Dane. Dane will be helping us out on the other end here while I narrate the update today. So what I got for you guys today is starting off with this the last 1 month time lapse, thermal time lapse, taken from the USGS Hawaiian Volcano Observatory's thermal F1 camera. This is a view looking from the west towards the east, and so the west vents down here at the bottom. As those of you guys have been watching our updates have become familiar with, there's our west vent. And it's been continuing to put out lava. That hasn't stopped, although the reports from the USGS update today is that it has become much weaker and slower. Right, so that's kind of the question: is how long will it keep doing that? We haven't seen since the beginning of the month. We were seeing lava on the back side, this east side of this big island over here. It's kind of more orangish color here at the beginning, and by the end you kind of see the lava recedes back during a big deflation, and it comes back up afterwards, but it doesn't quite reach this backside level right in here and here. Right, so that's what's happening. The lava is still coming out. It still seems to be filling the lake. There are still some pressure cycles. We have a deflation-inflation event that's kind of finishing up right now. And on top of that, we also have the lowest gas measurements reported to date at 600 tons per day. So we'll cover that in a little more detail here. But first, while we're on this thermal time lapse, I just want to share with you guys, I'm going to pause it here and I'm going to manually go a lot faster, right? There's kind of two things happening here. You know, we'll put it here towards a more current view here at the end, most current frame we have. So the lava's filling this kind of crescent shape, right? But really, it's shallower at this end over here, the south end, and at this north end. So that when we see the lava levels dropping, those are the level, that's where it's most clear that it does that, like as in this image right here. I'm missing in there, whereas this smaller kidney bean shape is where it's a little bit deeper. It seems like the surface stays open, active, and recirculating and repaving itself more frequently than this other part, which seems a little bit shallower. As you see, when the lava retreats, that becomes exposed. Right, so that's kind of the one effect, is the lava coming off and on. And really, since it dropped back down a few weeks ago, it hasn't come back up and reoccupied that east side of that island at all. That's thing one happening. The second thing happening is that even over the last month, you can see that this whole crusted over surface that's all floating on, there's liquid lava underneath there. And it might be gooey, it might be pretty degassed by now, but it's still down there and it's still able to buoy, lift this lighter, less dense crust upwards, right? Or at this point, you know, may become thick enough that maybe, I don't know if it could break through or not, you know, maybe if it were eroding, if it were more dense in some areas, but that hasn't happened. And so to really illustrate this, I really have to speed it up a lot. And so I'm going to drag it back and forth, and keep your eye on that back wall there and kind of see how that whole plate is rising upwards. So not only is the lava lapping on and off of those two bays, the North Bay and the South Bay, it's also going underneath it. So it may be that it's not lapping above it anymore because it's going underneath there more easily and lifting that crust up. And that part's not really clear because you can kind of see it takes the whole month of going back and forth to really see this effect. You really don't see it on a day-to-day basis, right? When you look at the 24-hour time lapses, you really don't see that. You have to really speed up here a whole month, like in 2 seconds and 1 second. You really get the effect of it, like I'm trying to show with you guys right now. All right, so that's the two things happening there. And so let me put that away for now and show you guys the most recent video that was released here from the USGS. So this is 17th of February, so it's already almost a week ago, but one of the more recent videos we have. And so here it is in real time, the lava bubbling out from this entry point below the west vent. This whole cone is above here. To the side, you only see the edge of it. And down here, you see this is our heart island. It kind of goes off the screen, its heart, like that. And you see there's more of the island sticking up now than before. There's a little bit of an edge right down here. And that's because the lava levels seem to be fluctuating a little bit up and down, in the order of 10 feet, 2 meters, 3 meters. But a little bit, and, you know, kind of staying hovering. It's maxed out at 218 meters, 718 feet. That's what it looks like most recently here. And another view of this, this is the S1 camera. We've created a time lapse by taking, once again, the USGS HVO's webcam images. This one's the S1 cam. And so this is all the frames, day and night. You kind of see it flashes back and forth. And this is now just the last week. So just the last week, cycling over and over here. It's like, well, didn't even cycle. Maybe I can cycle it if I put the cycling on. Here we go. You can kind of see there's our west vent. We're now looking from south to north. North would be more in that direction. And here's our crescent all the way down to here. You can't really see the South Bay as easily behind this rock here in the foreground, but it's down there, a little bit visible. And here's our, what I'm just loosely calling this North Bay and the South Bay. You know, this kind of crescent-shaped lava lake now that's kind of closed back in and raised itself up. And while going underneath, like a prey around this island and underneath the crust on both sides here and here. So have it in a loop and you really don't see a whole lot of change. It looks like it's just kind of doing the same thing over and over and over, and that's pretty much been the story. There's been those little variations up and down a few meters, but that's really nothing really that notable here. No big changes in the west vent itself, no real changes kind of on the island. We can still see down here we have a little nub that's visible on these nighttime images especially. that's still above the lava level, right? So the island, this main island level does seem to be a little higher, or the main lava level over here is a little lower, as we see all the other islands over here are also lower. So let me see if I can pull this on a frame like this, and maybe you'll have to, I'll pull up another picture, but we can start to see several of these islands getting exposed again, right? So that another sign of lower lava levels kind of across the whole active lava surface, rather than just only around this island, which might indicate just the island doing something. All right, so that's our S1 camera. And here are our SO2 measurements. And I think this is one of the more noteworthy things. It's not something that, it's just numbers again, but, our most recent measurement taken yesterday is 600 tons per day of SO2 coming out. And that's like half of what it was the previous measurement back on, that's this measurement here on the 19th. So our newest one is the 22nd over here. And wouldn't even register. Probably zoom it in so you guys even see. So there's this one on the 19th might have been 1,100 tons per day. This one might have been 1,200 tons per day. So we're now at half of that, way down here, right above this. This is a 0 right here. And so the overall trend, as you can kind of see, relative to 0, going back in time, we've been below this 10,000 mark for a while, right? Ever since this first week of the eruption, we came down below that threshold and crashing way down, right? We went way up and way down, as we showed you guys in our 2-month update last week. But ever since this point right here, about a month in, right, when it seems like we had that event and switch over, we've been below 10,000, maybe around 5,000, and we've been on a slow, steady decline with some little up and down variations. But to the point where now we're at 600, and it seems like that is the biggest challenge for the eruption, is to sustain itself without ending. It seems like that's really the major indication of waning, is that it's 600 tons per day is not that much, right? It's lower than a whole pool era coming out of pool. It's lower than a summit lava lake era. And you kind of wonder how long can it keep it up? So we know we're now past a 2-month milestone, and it's, we have to question whether it will reach a 3-month milestone at this current rate without things changing, right? And things could certainly change. We are seeing signs in the GPS of extension across the Kīlauea, and the overall tilt is coming up, even with a cycle is kind of interrupting it. So still to be answered, that could happen, or it could pause, or it could shift, but it's hard to sustain it at 600 tons per day. Maybe the lava is clogging up that pathway and can't get out as easily, and something will have to change, right? And most likely changes right around that same configuration at the summit, and who knows? And we could speculate, but no one really knows. We'll have to kind of wait and see. We've kind of discussed many possibilities in the past. So the actual text update from today, 600 tons per day on the 22nd, that's where this information is coming from. It's USGS once again. And the measurement today is 216 meters, 712 feet deep. So it actually peaked out over the weekend, a couple meters, 6 feet deeper than that. But because we are now in a deflation-inflation cycle, then it also dipped back down correspondingly as well. So 2 things going on there as well. One is that there's less lava coming out, and maybe it's less gassy, and so that makes the whole lava level sit a little bit lower, and that causes all those benches around the islands to form and around the edge of the whole perched lava lake. And then we also have I lost my thought there. Oh, that happens.
Yep, that'll happen.
I'm sure it'll come back to me at some point. I'll say it a little differently. So here's a tilt plot, and just showing that the tilt is something that's happening. Here's over the last week. You can see that we came down and back up on the order of, I don't know, maybe 3 to 5 microradians. We're up at +2 here, and maybe we're at -3. So maybe 5 microradians we came down. And we go back to the last month, and that's this little guy over here on the right. So kind of going down, and it hasn't quite come all the way back up and flattened out like we imagine. You can kind of see this long, steady, very gradual, slow increase here, right? And to kind of go back to the whole last month, it's been a slow, gradual increase there as well. Of course, that doesn't compare to the big drop we had earlier on, so it's kind of still piddly, but it's interesting to see that there is still an upward trend there. And what I was discussing with the GPS here, this is what I'm talking about. The distance across Kīlauea caldera summit, north to south, with Kahuna to crater rim, the local length here, and this is the past year. I'm going to zoom in over here. Our initial eruption adjustment where we relieve pressure, and then mirroring a deflation-inflation cycles, we've kind of had these humps coming up, but generally an upward pattern, and really you can kind of see maybe flattish in air, and certainly coming upwards all through here, you know, pretty steep, right? Steeper than we had before the intrusion on the second. Here's the intrusion on the second, and then here's the actual build up to the December 20th outbreak. And so maybe a little bit steeper there, but some of these areas, you know, looking like it's actually pretty loose in area. But you know, it's hard to tell if that's actually building pressure, or if it's like a loose tooth that's just wiggling around with every little pressure adjustment of that kind of, you know, bladder that's underneath it, holding up that caldera, which is the magma chamber, the shallow magma chamber under Halemaumau. Right, so that's the main caldera area. That's the 5-year plot. I'll keep going down, and we're zoomed in here. This is the Pu'u'o East Rift Zone line, and so similar north to south, and we can kind of see that the distance north to south is decreasing, so it's contracting. The sides are kind of coming closer together. It's still kind of just sagging in. Right, and so we're looking for when this pattern may flatten out, but it's not showing signs of that yet. And so that'll kind of show that the adjustment in that area might be over. But as it is, it's still adjusting, and maybe not surprising if we zoom out and look at the whole last year. That beginning in June is when it started coming up, and we haven't quite completed a whole curve there. So maybe it'll come down a little more, and possibly even beyond this level. Right? This is just kind of something interesting to look at. Right? All right, so that's our deformation plot there. And all right, so here's the view from the KW camera, last 24 hours automatic time lapse from USGS, and I'll zoom into it here so you can get a little bit of a closer in view. And then the same kind of view, just, you know, show you guys the thermal. It's nice to see these things and a little bit closer to true color, right? But you can kind of see there's our crescent lava lake right in there, our west vent. You can see a lot more of the gas coming out here in the visible view, and that's why we use a thermal camera so much, is it's consistent through the gas and consistent through day and night, and it's easier to compare things without doing as much work, right? So that's kind of the easiest way. And it also gives us temperature data, of course. It does that on top of that as well. So not a whole lot of change, you know, fairly stable within that circulation area right in there. And here it is, that S1 last 24 hours, not a whole lot different than what I showed you guys for the last week. All right, so looking at some of the photographs that USGS has put out, we'll go back to the 19th release, and here they have a photograph from the 17th. And we can kind of see here there is our entry point, that west vent, bottom of it, and our heart island is right here. You can see its heart shape a little bit right in there, and peeking above, that's kind of that view. And I might have to zoom in on it here to actually get a close-up view to show you guys. Here we go. All right, that's as much as we can get it. And there you can see that little elevated height right there. Right, and we were discussing last week how, trying to give you guys some scale, this might be about the height of a person in there, and you know, that's kind of, you know, might be like a bench you could sit on. Something like that. Of course, the lava level is rising and falling up to 10 feet, so you know, it's really that's a moving target there, right? And the whole thing is lifting up as lava is injecting below. So another challenge in trying to keep these elevations and heights straight and consistent. All right, so let's go back from that one, and let's yeah, there's a zoomed in view there. I could have just gone to that, but since we just did that, I'll keep coming down here. Here's the west vent. Viewed from above. So you can kind of see here, this is the area that's been putting on a little bit of spatter, a little bit less now than before, as what the caption says. Activity has decreased significantly over the past several weeks. The type of activity that they describe as small pieces of spatter occasionally ejected from the vent. And kind of more consistent coming out of the bottom down over here. Can't quite see it past the fume in that photograph. All right, so Moving on, a lot of good photographs to look at here today from USGS. Closer in view, you can kind of see this levee over here, and maybe we'll open this one as well, and another tab to show you guys, try to zoom in on that, because that's an interesting feature. This is on the 17th once again. And we will click in and click in and get the closest possible view of this, right? So you can kind of see a little bit better here. There's a lot of chunks of lava slabs in here, all this stuff all through here that's making up the levee. So this is actually higher, and then this down here is lower. Here's like a little place, like a little gap where lava spilled out, right? And kind of made this little lava delta right there from this higher to lower spot. So they've described this in the captions. I'll have to go back. The levee is formed from numerous small rafted crustal plates that have stacked upon one another and likely fused together. Photographed by Matt Patrick, February 17th. So that's really fascinating to look at in a little more detail, right? We talked about how the lava might come and spill over and actually layer, and that's the part that's possibly fusing it, because it possibly not only goes up and over, it possibly injects through it, right? We know that it's gone all the way under and squeezed out the edge. So certainly there's some pressure that could inject into the cracks and fuse that together. And that kind of is something that you see in some of the wall rocks at Kīlauea and some of the areas like that. So interesting that it's not just the lava spilling over, right? But that maybe when this crustal foundering is happening, like you see a little bit right here. Here's a big chunk of crust, right? And there's like a crack over here with lava coming out of it at the beginning, and a bunch of lava coming out over here. So this whole piece of, and here's lava rolling over it from this direction. You can kind of see a seam right in there. And this piece right in here is gonna get swallowed in, and it's even breaking apart over here. Right? And so there's chunks of these rocks that are circulating, getting pushed, and maybe it's pieces of this kind of thing. If it happens right at the edge, it just gets shoved onto there, and maybe that helps out, right? Maybe this kind of pattern right here, where you see plate that's kind of stacked up on the edge of the rim of this thing. See if I can get it any closer. It's starting to get blurry, but maybe not as much if you guys are watching on a phone or something like that. But kind of like that guy right there, and this big plate right in here. All right, let's blur it. Look at that one. This one's standing on edge right in here. You can kind of see this. There's a whole interesting dynamic with all these plates on the lava lake, right? And in fact, it goes back to the 1970s when it was described at Mauna Ulu lava lake, how this was a great model for plate tectonics and how the plates of the earth form and spread from upwellings of heat below it and all of that. So that'll be a story for a different day here. All right, let's move on from that photograph. And one last one released on that first release, and that's a review. So we've seen an image like this before, very similar. This one is very similar. The big difference is this arrow right here and label that says surface east of the island no longer has active surface lava. So the last photograph that was a thermal still had lava on its backside and no longer on this one over here. And so that's what you guys are seeing there. And that's no surprise. This we've been talking about for a few weeks now. And there's our South Bay and our North Bay. All right. So worth noting, this warm ring is still over here, right? It's still coming up everywhere around the edge, and maybe it slowed down a little bit during the deflation part of it, but it still seems to be fairly persistent overall that it's happening over the last month. Okay, the release that was out yesterday, backdated to the 19th year. You see a view of two HVO geologists using a laser rangefinder to measure the distance to Halemaʻu lava lake. So you can kind of see that there. There'll be another one of that, and the video we showed you guys a little earlier. So the release for today, let's open this one and then zoom in on it. This is a picture from yesterday. So I'll go down here and click on the original, show you guys how to navigate this USGS website. And all right, so you can kind of see the picture from yesterday. We now have the this bigger, close to the vent island connected to this other smaller island over here. I guess almost forming a crust in between them a little bit. Of course, there's more to these chunks of rock than is visible above the surface. So, you know, there's some base that maybe extends more this way, and maybe this one extends more that way, and it's hard to exactly tell how they might be related beneath that surface of the lava, right? But clearly you can see the main flow is going all the way around here now, and all the way around here. That's interesting. And this bench over here looks deeper, where you almost see an exposed little puka, a little hole. Let me zoom in on that. Getting blurry again, right? But our main exit point's been over here. And so now we kind of see that there's this built-out bench. It's almost like it's hanging over, right? It's like a overhung. It's undercut, or the lava is still liquid underneath there as it's dropping down. It's maybe not. It's interesting to see, you know, how this stuff will stay supported, or if any of it starts collapsing at some point, right? And speaking of collapses, maybe we'll see some photographs of that here coming up. So interesting, small little side feature. And these are the small kind of changes we're seeing now. You know, as we're hearing the amount of lava coming out, the amount of gas coming out is less, but it's visually not that different. You know, it's been fairly slow for a while compared to that first couple weeks. And there's another island visible as well. A couple more down here.
We have a $9.99 super chat from Jay Roller. He says, "Thank you for dropping science, guys."
Mahalo,
Thank you, Jay. Appreciate it.
Mahalo, mahalo. Let us know if you got a question, Jay. All right, so that's interesting right there, and you kind of see a little bit of this crustal overturning and foundering happening over here, right? So not quite as strong a flow or as constant a flow in these back sections. You see here some of these old chunks of crust kind of trapped in this younger matrix of lava. Interesting textures right in there. All right, let's move on from that one as well. And you can kind of see here, we'll zoom in on this one too. This is a zoomed in view on the island, so click all the way through to the original once again. And zoom in, I'll start right over here with this feature we've described before. There's this kind of cape, right? This long little peninsula that's just barely above the lava level now. I mean, this might be 10 feet tall. It's hard to really tell distance in there, right in there. If that's a variation that's been going up and down 10 feet, maybe, you know, maybe that's 10 feet or more. But still, that's a much smaller feature than this big cliff. If I pan over here, there's a much bigger cliff right over here. Right? And actually has a flat spot of lava on the edge of it at the surface. So that's when the lava was much frothier and it was coming this much higher over the edge of the island. And only from here and inwards do you see that cinder surface preserved, right? You can kind of see it's been steaming for a long time, and gas has been coming out of the lava, probably through cracks and through that really porous, right? We think it's relatively, it's less dense than the rest of the lava in some way. Maybe there's trapped airspace, or there's a space between the chunks of tephra that are all stuck and welded together. In any case, the gas seems to find some way up and through that, and it'll steam out of the cracks in the top. And just like on the crater walls, you see some of these deposits or alteration of the rocks. Alteration meaning the high temperature and water content, the steam is helping those rocks to react and form things like oxides, or, you know, clays or whatever that you might have on the rock, right? You know, I won't go any further in there. Can't give you guys much more detail on the breakdown of the mineralogy there. But interesting to see that, right? And there's that main cinder cone surface up to this peak right in here, right? There's kind of a high point somewhere up here at the top of this cone. So, all right, nope. Let me go back to that, and let's just zoom out this way. So you can kind of see it's interesting. We still have some sagging around this lower bench area, it seems, on this north side, and it's interesting that maybe even though lava is not flowing over top of the surface on the backside here and here, maybe it is still injecting underneath here. And this crust is thin enough that it can still sag down relative to the lava levels, lava density perhaps, gas amount, gas content changing, right? So that's something we're curious, keep an eye on as well. All right, so we'll back out of that one. And here's an interesting view of the Western Fissure. And maybe, I'll open that one in a new tab also, because that's worth zooming in case you guys are watching on a small screen. And click through to the original. And you can kind of see here what they're describing as little lava driblets kind of oozing out of the side of that west vent, right? So here's the top of it where the spatter comes out and where the gas comes out. And it's interesting, right? And lava seems like it's been oozing out. It's made this kind of, sometimes this is called entrail pahoihoi or something along those lines, right? It kind of looks like entrails in some ways, or little driblets. There's a different kind of textures you can call it, and maybe not quite. Maybe it's not quite entrail enough, but that's kind of that's getting close there. And dribbling down a side, so that might tell us that even if lava is coming out slow from that bottom part of the vent there, maybe there is still enough pressure that it's trying to come out and it's just kind of plugging itself up and it's leaking out a higher up point of the vent, right? That we haven't quite seen. So it'd be interesting to see if this is like a transient thing or if this kind of stays sustained, and maybe we get a reconfiguration. Lava comes out a little bit higher, right? Just like the north vent got drowned eventually and lava stopped coming out of it. At this point, this bottom part over here, here's where we're just zoomed in on, and here's the actual lava entry surface way down here, right? And remember, this thing might be 100 feet high, right? So we're talking about a 10-story building, more or less. So somewhere on the 5th floor, there's lava oozing out from there, 50 feet up from where it's coming up down here, right? So that might indicate some kind of back pressure, because we have seen the level of this vent has had to rise as this whole lava surface has risen as well. It has also had to rise up. So the original entry point was much lower, and lava has to kind of go down and up. And at some point, you might think that could become a drowned vent situation too. Only time will tell if that actually happens. And you would think that if it was only that you would still have lava bursting out of one of these other sides over here and putting out more gas, especially because the gas maybe is not as restricted. Maybe it is. Maybe this clog is more than just we see at this shallow surface part. Maybe it goes further deep than that. And once again, it's interesting to think about, but we just don't know for sure. All right, so we're almost to the end of the photographs here. One last photograph here of a HBO geologist using a sketch in their field book to note the location of laser rangefinder measurements in the lava lake. Right, so you can kind of see that you have to point a laser rangefinder to certain areas and kind of make sure that everyone is doing it the same way on different shifts. You want to make sure that you're documenting exactly where you're going with that, right? So let me...
How's that advantageous to saying just pulling out a cell phone and taking a picture of the azimuth of the tripod or the rangefinder there?
We could do the azimuth, right? But the person knows what they're looking for and what exact point they're measuring in between.
I'm
right?
just curious.
But yeah, there are people who do like to use digital photographs and annotate them digitally, right? He's using that traditional geologist write in the rain notebook that's waterproof and a pencil, so he can be using that in the middle of the rain. And usually that's where the tablets kind of fail, is that kind of situation.
Right, in the rain.
So it's just, I don't know, that's tried and true. It works, and I can. I don't think I'll embarrass him here, but we can actually zoom in here.
See what he's drawn.
Yeah, and you can actually see, right, how good his drawing is, right? This is a good geologic drawing, right? He's not drawing like the actual artistic parts of it, but just the main geologic features, the raised edge of the perched lake, that main big island over here. He's measuring the elevation of these other islands over here that are stuck in the crust, right? So that's what maybe it's not exactly accurate left and right. Cool, you can see he is using graph paper. Yeah, he's doing a good job. And so you can kind of see, like, this is a point I'm measuring between the top of this point and a lava lake right down here, or I'm measuring between the top of this island over here and lava lake down here. And so, or the lava surface beneath the west vent and what have you. So pretty cool. Good job. I believe that's Brett. So good job, Brett. All right, so let's put that one away. And one last photograph here that's we've shared already. I believe we shared it already today, Dania. Here are the double rainbow formed over Halemaumau crater, and maybe I can go in on that one a little bit more too for you guys that
Right, and the thing that it's crazy to me because this is probably the third or fourth like double rainbow situation out of the caldera from the webcams. And if you remember in 2018, there was some phenomenon we were trying to capture on the webcams, but it was incredibly hard. Thinking of mostly of the lava nados that would form over the lava channel, right? These tornado vortexes that would come out of there. And the thing about the webcams and the webcams that are still being used now is they take one frame every 5, 10, 15 minutes, usually 15-minute intervals of what we were dealing with then. So it was even hard for people on the ground with those lava nados. They would they'd see it, try and get their camera out, their cell phone out, and then it would be gone by the time that that they got it out. But they were very common. But it took us probably a month before we got some decent images of one on a webcam. Right, even though there was multiple cams looking over there. I'm like, these rainbows must be so common up there right now, like more common than not, almost to that point.
Yeah, rainbows are very common at Halemaumau. That's one of the magical things about the area, right? Because it's right at the crest of Kīlauea, right? Where Kīlauea isn't the tallest mountain by any means in the island, but it does have a crest, and so it has a upwind wet side and a downwind dry side, and a climate change right in between there as everything goes over the top of the summit and essentially can decompress, right? And so you often have rain clouds that kind of just vaporize into mist, and by the time they get over the west side, that's it. And so depending on which point of view you have, you may always be looking, many times looking through mist. And it's awesome that these cameras are catching this, right?
Right.
Oh, really cool. I'm not sure if this one may not be. Is it the webcam itself, or is it actual someone taking a picture? I think this might be someone's.
This might be a kid picture. Yeah.
But yeah, there are some good webcam ones, and we do have some kind of compilations going on some of those that we'll share at some point. But oh, I went back too far. So it does not say here.
Poor boiling leprechaun at the bottom of that rainbow.
Yeah. Yeah, I'm sure this will bring up the typical questions and the comments. People talk about how gold is often associated with volcanoes and hydrothermal fluids, like all the water flowing around at the edge of the magma that long after the volcano is dead and cooled and uplifted and exposed, that you can go and mine it or let the water mine it out for you and look for it in rivers or that kind of thing, right? And there's gold down there somewhere, right? We're not getting into it.
Right.
So all right, that's the double rainbow. And just to make sure we cover all our bases, here are the earthquakes. There's still been continuing activity at the summit of Mauna Loa. Kind of still low level, but ongoing. She's still building towards an eruption at some point. She's been doing that for years, and until she changes gears, she's just still slowly building, right? And even if we see all that pattern, it's, she hasn't stopped. All right, we have over here the South Pahala Deep Cluster. That's the hotspot source wherever it comes into the island, maybe possibly feeding to Kīlauea and to Mauna Loa. And possibly Levee. I'm not sure, exactly how that breaks down, but those are the candidates right in there. And we can zoom in on Kīlauea a little more, and we can see that there's been one earthquake right there, 0.8, right at the eruption site. So maybe there is a little bit of, who knows? Interesting to see, why that's, it's just one small earthquake. Certainly nothing to be alarmed about, but we'll see if there's a backup, then you might imagine earthquakes could build up as well, right? But one earthquake is not a buildup. It's interesting that there is one at all, since we haven't seen hardly any. And on the south flank, it's just been here's one kind of south, 2.3, at that same south flank depth, and all the other ones of these were longer than a couple of days ago within the last week, but it's still happening slowly. And kind of background ones over here on the north part of the island, Mauna Kea and west part of Mauna Loa. So not a whole lot to see and talk about there. And of course, we started off talking about the gas, and kind of we'll bring it back around to the gas, even though if there is just the lowest amount of gas coming out, it's still 600 tons per day. That's still something, that a factory wouldn't get away with. So it still has effects downwind in southwest Hawaii, and some, depending on how much the winds blow it around here to this Kona area, right? It's in the leeward part of Hawaii Island. All right, so that's what we have for the data today, and we do want to share some of our contributor images to Hawaii Tracker. And this is Harry Durgan. And here is his Crater Rim Trail, February 19th, almost 11 p.m. And so a great view here of the ohia trees and the staghorn fern down here at the bottom, and you kind of see the glow on the back of the crater wall here in the background. I'm not sure if I'll be able to zoom in a little bit. I can, yeah. So to give it proper credit, you gotta go on Hawaii Tracker and check it out yourself. All right, so mahalo, Harry. Next up, we have Warren Fence. So another great composition here. Gonna see the glow of the crater there, and you can kind of see some shooting star there. It's in motion, or maybe it's a satellite of some kind. It's kind of hard to tell just from this, but it's in motion up there. Nice exposure there. You can see the upper cliff and then this down drop block. Right, so probably looking from north to south, I'm guessing. Mahalo, Warren. Great composition there. Check that out on Hawaii Tracker. Next up, Tyson Kaparimo and Kīlauea Overlook, double rainbow. Daytime view there. Mahalo, Tyson. And we'll come back around and with Harry Durgan once again. Dreamscape, Kīlauea Iki Overlook. They're really fantastic. Looks like a painting almost there by Mr. Harry Durgan. Mahalo, Harry. All right, Dane, that's it for our photographs. So I just want to make sure that we mention to you guys that we are brought to you guys by Kaleos, innovative Hawaiian-inspired local cuisine. Check them out in Pahoa Town on Hawaii Island. It's Dane's neck of the woods. So what do you think, Dane?
Yeah, definitely the place to go in Pahoa for some fine dining, some local twists on some more traditional dishes. Good fish, really good fish dishes there. Known for their ribeye and their tremendous cuts of meat there. Steaks, all kinds of different ways to just from entrees to appetizers. It's really top of the line there. And competitive prices too, right? A lot of people think of it as, it's an expensive place. Not really. It's pretty competitive compared to the other, establishment or other places available. And just great all around variety. Some of the great drinks there. The burgers are insane. Just real good stuff.
Which is these things here on the screen? Have you tried, Dane? Coconut crusted fish, lilikoi cheesecake, Calbeek steak special,
lilikoi margarita.
Sesame
on that
crusted.
One and the prime rib and the
dynamite fish.
That lilikoi margarita. I haven't tried that one. I'm not really one of the adventurous eaters that goes out and tries. I just find like two dishes that I like and then just figure out which one I feel like that day. So it's really good food though.
Yeah, great family dining.
And we appreciate
open for dine-in and takeout. Yeah, go ahead, Dane.
Yeah, we appreciate them being sponsors of Hawaii Tracker.
Yeah, mahalo.
Yeah, they also do prior to COVID, they were doing live music, all kinds of entertainment for people. And since COVID, kind of on the more low key, the outdoor dining is available and used much more frequently now. Also available for takeout.
Right on.
All right. So let's get into some questions. But before that, I do want to thank Hawaii Tracker for helping make this possible. Hawaii Tracker is a social media site that is a little bit alternative to the ones that you're used to. This is a community building site focusing on the community itself. Best way you can help us out is to share this video, like, subscribe, those types of things. We don't have a media team. We don't have marketing department. We rely on your word of mouth to help share this information, share this video. Other way to help is to go on hawaiitracker.com, become a member, become part of our community, and maybe then consider making a monetary donation, which does help us continue to do the research to be able to provide this type of content for you. We appreciate all the donators that we have. and let's get into some questions. We got some good ones today. I did send you some images in Telegram for the first question.
Okay.
First question is from KL that asks, was watching, and this is also a question from Twitter, very similar one, was watching Etna yesterday that was pumping lava jets 800 meters, 2,400 feet high into the sky. Is such a thing possible at Hawaii volcanoes? And the links I gave you are Kīlauea Iki and Pu'u'o.
All right, so I'll bring them up here. So here's the first image. This is the tallest lava fountain measured of Hawaiian volcanoes, Kīlauea Iki. You can kind of see, maybe I can get to the original here and zoom in for you guys. Oh, no, it's not very big, but I'll still zoom in for you guys. You can kind of see the red part of the fountain goes all the way up to somewhere in here, and all this black stuff's all the tephra, the Pele's hairs and Pele's tears, and all those chunks of rock that are flying downwind, already cool enough to be black, right, rather than being red. So 580, that's the Hawaiian record, and of course the Hawaiian record only goes back to when we had Western scientists measuring these things with whatever triangulation means, and their units that they brought from the West. So 800 is taller than we've seen. Certainly we could have had lava fountains that might be in a range of 800, but Etna does have lava fountains that go up several, sometimes 2K, and that we do not see at Kīlauea. So that fundamentally Etna does have taller lava fountains than Kīlauea does, and they're more episodic. I mean, I guess ours were fairly episodic as well, right? That's kind of one phase of it. We can talk more about eruption styles maybe in some future discussion, because there is some interesting stuff recently coming out about that. But ultimately the answer is no, that we don't have as high fountains on Kīlauea as you have on Etna, right? Here's Pu'u'o, which from Pu'u'o, and Pu'u'o might have gone up to maybe instead of 1,900 feet, it might have been 1,800, 1,400, 500 feet. That's how most of our fountains are. Mana'ulu, 1,800 feet, 1,500 feet, 1,400 feet. That's the range of our fountains. 1,900 feet being the tallest at Kīlauea Iki, 580 meters. So yeah, ours are impressive, but it's not like Etna. Etna's in a whole nother, league of its own, right?
Yeah, still impressive fountains.
Yeah, here's a last image that Dane sent here, and that's almost 1,500 feet, pool 445 meters.
Getting up there.
Yeah, these are massive fountains that are nothing to sneeze at, right? Yeah. They're putting stuff way downwind. But that might
people
be...
weren't people in 2000 or when 1960s when Iki was going off at its 1,900 foot fountains, able to see it from some pretty ridiculous areas.
People did go to the upwind side of it, and they could get right across, because it's near the north end of the crater where it closes in. So you could, initially when the event was still small, the geologists walked down and walked right up to it, and eventually they kind of backed off. But you could still, at the top of the crater rim, see pretty well, and when it was at your back all the time, and that was all well and good until something clogged the vent. A big chunk of like one of these islands during a drain back clogged the vent, and then it came out and it sprayed right where all these people had been. It happened in the wee hours of the morning, thankfully, and no one was injured or there. But the next day, the evidence was all lava plastered trees and ground and everything. So eventually that Peace Island got dislodged, right? But yeah, these are massive. There's a version of this picture that has a helicopter drawn in, and it's like something like that size, right? The helicopter. So these are massive fountains, for sure.
The one I was thinking of is, I remember some people, some old timers that I was talking with that were saying that they were living here on the island at that time, and their house, I cannot remember where they were exactly, but it was something like they were in Mountain View or somewhere on the slopes of Hilo, and they could see the tip of the lava fountain, or what they thought was, at least, coming from Iki. Most
people all around all of East Hawaii could see that, right? Mauna Loa kind of blocks the view for everyone on the other side, right? But yeah, people talked about how it was bright enough to read books at night. Miles and miles and miles away. People went surfing, like in Kalapana, because you can see, so it's these are certainly massive, right? But Etna is just a whole next level that we can't even imagine here. Like a 2 kilometer, 2,000 meter high fountain is a whole different thing than 580. It just is, I mean, ours are this is nothing to sneeze at, but Etna is just bigger. It's just all there is to it. I mean, and it's not about, it was just different kinds of plumbing and different kinds of lava and different gas content and all of that. So that is it's interesting to compare them, but in the end, Etna does make higher fountains than Kīlauea. Yeah.
All right. Next question is from Mr. Bob on YouTube. Lacking SO2 gas, what is pushing the current flow?
Yeah, the gas levels are low, but they're not zero, right? 600 tons per day is still a good amount of gas. And it could be enough, to be bringing it up at that slower rate potentially, right? It's just not the same as when we saw it just gushing out of the ground, right? When those first couple of days we're having estimates, and who knows, we'll have to wait till everything's published till it's all said and done. The rates were like 60 or 70 cubic meters per second, more or less. Right, and and now we're saying long term we're at maybe most of something I heard was 4 cubic meters per second. Which is a long term Pu'o'o rate, 4 cubic meters per second of eruption, right? So what if we're down to 2 or by 1 cubic meter per second? That's still enough to put a lot of stuff into the lake, and we believe that's why if you don't put as much in and it's less gas rich, that's why I would believe the lava level has been dropping when it has. It's been, kind of dropping a little bit when lava's coming in a little bit less, and when a deflation happens. But before the deflation, it was dropping a little bit, kind of hovering around this level where it is now. And it's probably just because there's less gas in it. So, we don't necessarily need any draining anywhere deeper down. It could be happening. Maybe we'll never know to what extent. If it's happening some small amount, we might just not know. But overall, there's no real need for that because the volume loss is enough that you could account for it with just like degassing going on. I mean, lava is super frothy, right? It's almost like you imagine like a bubble bath or something. All this foamy bubble stuff. It could compress quite a lot, depending on how much gas you lose. Even if the bubbles go from being this big to being this big, that makes a difference in how high the foam sits and all of that. And so there's all kinds of, think about like a cooled lava rock that you pick up on Hawaii Island. You see all the gas, all the bubbles frozen in it, like even with usually the most dense ones. Usually to have a dense thing, it's going to have cooled all the way underground, right, and have totally degassed. And that's unusual to see at the surface.
All right. John Flavel, I hope I pronounced that right, did a $5 super chat with a keep it up GIF. And I also have a question here from him that he submitted. So if this vent is covered up, I assume the western vent, if this vent is covered up, would the drain back cause another vent to form higher up?
Yeah, it certainly could. Yeah, and we mentioned that that's a possibility, and there's that lava seeping from halfway up already. So yeah, quite possibly that could happen. Or it could be that it's all about what the signals actually mean. We see these signals at the surface, and we kind of try to interpret what is happening, right? We may be a little more adventurous with our interpretations than the official government, and that's totally understandable. Right. But we're still just guessing what the signals are a result of what's happening underground, and it may not make sense all the time. And so that's where we are now. Is we have the paradox of the gas amounts going down and the amount of lava coming out is going down. But we still see extension across the caldera, and we see a long-term tilt, slow increase, as if there's pressure building, maybe in a place not linked to where the lava is coming out right now. That's the question, like why exactly what? Maybe this batch of lava that's erupting now got pushed by one from below, and maybe as this one is petering out, that one's still arriving. Who knows? I mean, that's the complication of not being able to directly see down there in real time, but have to kind of interpret from the earthquakes, from the tilt, from the GPS, from the thermal, from the gas, all those things all together, right? And that's really what HVO is doing all the time, is they're integrating all the experts in each of those fields and meeting all the time to say, okay, what makes sense for us? And then when they have enough to share, they do that, right? And so we say, well, it could be this, could be that, could be this, could be that, could be this. We don't know for sure exactly what it is. Yeah, certainly a new event could form.
Right. Well, thank you, John, for the super chat. Let's get on to the next one. Nicholas on YouTube asks, is the lava that we're witnessing, or actually, let's go with this one. Is the whitest color, I'm assuming on the sides of the wall of the recently hardened lava and some of the stuff in 2018, is the whitish color caused by calcium or silica impurities in the lava?
So depending where the whitest stuff actually is, usually the easiest whitest stuff to find is calcium sulfate, something along the lines of gypsum. So that could be it. If it's a discoloration on a rock, you certainly can have silica, but that usually is something you get more. I'm not sure what kind of hydrothermal process is happening at what level you get that. Silica might be deeper in the ground where the silica is coming out, but certainly you can have silica depositing as well. That's kind of dissolved in the hot groundwater around there. Yeah, and sometimes you have like that whitish with yellowish patches, right? So you can have more of the elemental sulfur mixed into the sulfates that are on there. So those are the best guesses, without really having something specific to go on, and probably couldn't get a sample anyways. Here it's hard to say for sure.
Right. All right. Well, we have another $5 super chat here from Dave Pruitt. He says, "Thank you so much for doing this, guys. Good updates, fun chats. Definitely. Thank you for the donation. Appreciate the super chat." I don't think I have one of his questions here. Let me check. Nope. Oh, I do. Dave asks, what was the gas rate 2017 before the last eruption during the previous long-term lava lake?
So they say that the average long-term amount was 5,000 tons per day. 5,000. So now we're at 600. You might say that, I might, maybe bracket it instead of saying, well, the long-term average, because it fluctuated quite a lot. And that's kind of one thing that seemed to be interesting, is that we could only measure gas in the past maybe once a week or something like that. It was hard to get it at a finer temporal resolution than that. And then as new technology was deployed, you were able to do it every 15 minutes, for example. And then they found that there was some relationship between deflation-inflation events and lava level at the surface dropping and rising with gas releases as well, right? So that's something that kind of was new, that was found. And so, it could be that there is a added effect of our deflation-inflation cycle happening now on a low amount of gas, because that measurement's from yesterday during a deflation cycle. Still, that's kind of shockingly low for it to persist, right? And if it goes back up to 1,000 in a couple of days because we're back in an inflation cycle, then that'll be telling as well. That kind of brackets it, right? So the bracket of 2008 to 18, I would put it between 2,000 tons per day and 6,000 tons per day, more or less, something like that.
With right, a 95% confidence interval, or like 80% confidence interval?
Yeah, just kind of that's with no actual math being done, just like memory of having looked at the updates every day for that entire time and like seeing the range of it. Most often it's in the 4,000s. So I can see 5,000 for sure. And then certainly there were times where it peaked higher, and certainly early on it was a lot higher. It was more in a 10,000 range. But rarely was it 600, right? It was kind of 2,000, 1,000 might have been like maybe during these kind of drops in deflation inflation kind of thing. But yeah, that's 600 is pretty low any way you cut it compared to that 2017 era, for example.
All right.
So maybe one last one to finish up here.
Yeah. Let's see. What's a good one here? Rhonda asks, so where would lava be going if the lava lake is going to stop? Like, is lava going to stay there? Is it going to drain back? And what does it drain back into? What is the system? Is it?
Yeah, so I mean, when lava stops coming out, we might have more of our answer as to whether something is draining or not, because there's some amount that you expect it to, like we're seeing now through gas loss, it loses volume. So that's some part of it. And if you see it go beyond that, then you might see, okay, we have to add some draining, and some draining must have happened. And then you might see, here's our candidates, and you might look at the deformation on the surface to see if some areas are sunk in more than other areas, because as it's trying to drain, it's going to be hardening on a surface very quickly at the same time. And so you can probably get some, with the cameras we have, photographing as often as we have, we might get some indication of where that's actually happening. Now, one thing that we saw at Kīlauea was the whole lava surface kept crustal foundering for over a week after the eruption was over, just from the remnant heat in the pond. So that could be happening as well. So you got to make sure you capture it before it erases the evidence of what's going on. But that's kind of thing you'd look for. And yeah, so mahalo you guys for all those great questions.
Yeah, definitely. So what was the level of the previous lava lake? We do have just one final follow-up question on that. Previous lava lake?
It was probably about 900 feet higher than the current one is right now.
900 feet higher.
About 900 feet higher. So 1,600
All
feet
right.
above that very bottom pit. Yeah.
All right. Well, that does it for me. Appreciate everybody that got their questions in. We did have some good ones today.
Yeah, mahalo you guys.
And, yeah.
Thanks for the questions. Thanks for your support. Thanks for all the donors and all you guys that are supporting our work here. And we will be back to get with you guys on Friday, and we will sum up the rest of the week here and see what is happening with this eruption, whether it truly is waning with this gas level going down, or whether it comes back up and it might pick back up, or whether something changes otherwise. And if something does change more drastically, we might cut in sooner than that. But until that is needed, we will plan on seeing you guys on Friday. So mahalo you guys. For Dane DuPont, I'm Philip Ong. Aloha.